So these are the notes for 17.1. The big topic we're going to be talking about here is the triangle proportionality theorem. In Module 16, we talked a lot about similar figures, and all of that is kind of leading up to this. This is kind of the big part of this section, is this theorem right here. And so typically, if you looked at a diagram like this, in the last section, I pretty much told you to redraw it so that you have two different triangles, right? We would have had triangle AEF, and then the bigger triangle ABC. And so now in this section, because of this theorem, it says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So if I know for a fact that those two sides are parallel, okay, if they're not parallel, this does not work. So you have to make sure they're parallel. But then I can say, okay, well, this distance here from A to E and this distance here from E to B, that ratio has to be the same as A to F and F to C. So this fraction right here. Okay, I no longer have to split it into two triangles. I can just simply say, okay, this top left part and this bottom left part have to have the same ratio as the top right over the bottom right. Okay, so that's essentially what this fraction is saying here. It's your top left over your bottom left has to equal your top right over your bottom right. And so that's nice because now I no longer have to separate my triangles and figure out which two triangles I'm using and corresponding sides and all that stuff. And it just makes my life usually a little easier to work with. So it says given that EF is parallel to BC, so this line EF is parallel to BC. They have little markings here, so we're good to go. Two little parallel marks. It says go ahead and prove that AE over EB is proportional, is equal to AF over FC. So again, we're thinking top left over bottom left equals top right over bottom right. So to prove that, it says that first we want to show that those triangles are in fact similar. So if we did actually split these triangles up, right, like we did last time, AEF, that's not an A, and ABC, because those lines are parallel and we have these two different triangles, we can conclude that angle 1 is congruent to angle 2 and that angle 3 is congruent to angle 4, because you notice we have these two parallel lines cut by a transversal, and those are corresponding angles. So those are congruent by the corresponding angles theorem. So since we have these two sets of angles, right, we have angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. That is enough to say they are similar by angle. So we know that triangle AEF is similar to triangle ABC by the angle similarity. So in step 2, now that we know that those are similar triangles, we want to prove that those are in fact proportional. So our first step says that AB is proportional to AE. So AB and AE, because those are corresponding sides of our triangle here, the two left sides. So AB and AE. And those are going to equal AC over AF, because again, corresponding sides are proportional since we know that the triangles are similar. Then if we add the, if we look at the top here, we go from AB to EB. Sorry, we go from AB to AE plus EB. And so if we look at our first original triangle, from A to B is made up of AE and EB. So that whole side we can write as this. And so if that's the case, then I can write my other side from A to C as AF and FC. So we're going to write the top portion as AF plus FC. And again, our denominator is still AF. And that's by the segment addition postulate, right? The longer segment is made up of the two segments added together. And since we have an AE over AE, any number divided by itself is simply a 1. And we're going to use this property that says that A plus B over C equals A over C plus B over C. And I think that's actually a typo. That should be A over E, not A over B. And so we're going to have A over E plus A over E, or sorry, A over E, AE over AE, which reduces to that 1 here, because anything divided by itself is just 1. Then we have EB over AE, because that's the other part of that fraction. So those two. So then on the right side here, we're going to have AF over AF, which reduces to 1, plus the other side of my fraction is just FC over AF. Since there is a 1 on both sides, we're going to subtract the 1, and that is our subtraction property of equality. We're subtracting 1 from both sides. So those will cancel, and we're left with EB over AE equals FC over AF. And if we take the reciprocal of both sides, I'm going to just flip those over. And again, that's true. That was one of our properties from 16.3. That as long as you take the flip of both of them, you are okay. So we're going to flip the second fraction just like we flipped the first. And therefore, we have our proportion AE over EB. Right, top left over bottom left equals top right over bottom right. So we're good. So that is it for the triangle proportionality theorem. Again, the big idea is that your top left over your bottom left will equal your top left over your bottom left will equal your top right over your bottom right. We're going to write that in our fraction over here to the side, right here. Okay, so that's the big idea we're going to use here. Therefore, we don't necessarily have to split it up every time. You still can, but that requires a little more work. So that's why it's nice to have this little shortcut here when those two lines are parallel. So again, that's the big idea there. We have to make sure those are parallel first. So actually putting this into action, we're going to apply this here. A couple of example problems. So number 2, we're going to find Pn, and sorry it's a little, I don't know why it got angled so weirdly, I apologize. So number 2, find Pn, and one thing I'll say is it can be a lot easier if you redraw your triangles so that the two parallel lines are down at the bottom. So if I redraw them here, the angle at the top, I'm pretty much going to take my triangle and rotate it up this way. And so that's going to be angle N up here at the top. We're going to have Q going down the left-hand side. We're going to have M all the way at the bottom. Then on the right, we'll have P and then L. And then doing this becomes really easy because now you have your top left, your bottom left, your top right, and your bottom right. So using the triangle proportionality theorem, we're going to have NQ over QM equals our top right, which is NP, over PL. Top right over bottom right. So for NQ, we know that that's 5. QM we know is 2. NP, I don't know what it is, so I'm going to call that distance x. And PL we know is 3. Now we can use our cross product property, multiply diagonally. So we get 5 times 3 equals 2 times x. 5 times 3 is 15. 2 times x is 2x. Divide both sides by 2. So x equals 15 over 2. So it wanted us to find that distance of Pn, and that's going to be 15 over 2. So it's that simple. And again, that's what's really nice. Knowing these lines are parallel, we can jump straight to that theorem if we reorganize our triangle and do our top left, top right, bottom left, bottom right. If you can see it in your head without having to rotate it and redraw the triangle, that's totally fine. That's just a tip I give to you for some people who have a hard time seeing kind of which sides to use where when you're setting up your proportions. So if it helps, totally redraw it. I think it does really help a lot for many students. But if not, that's totally fine. I'm going to continue doing it. So for those of you who do it, can make sure that you're doing it right. But you absolutely don't have to. So for number 3, again, I'm going to redraw my triangle. It doesn't have to be perfect, but draw it so that your parallel lines are kind of at the bottom. Which if you do that, that means we're going to pick this up. It looks like it's a tree that kind of fell over. So we're going to go up this way. So that's going to be angle A up at the top. Then down the left-hand side, it's going to be X and B. And the right-hand side is going to be Y and C. So we have our top left, bottom left, top right, and bottom right. So we're going to set up our proportion top left over bottom left equals top right over bottom right, which is, according to our triangle that we redrew, AX over XB equals AY over YC. So if we look at our diagram, the distance AX is going to be 9, XB is 4, AY is 10, and YC, don't know what it is. I'm going to call it X. So again, use our cross product property, multiply diagonally. So we get 9 times X equals 4 times 10. So 9X equals 40. Divide by 9, divide by 9. X equals 40 over 9. And so that distance from Y to C, 40 over 9. And so it says find CY. CY is 40 over 9. Okay, so again, that tip, if you can rotate it over in your head or if you can see that without having to do it, that's okay. But go ahead and redraw it. Okay, I know it seems like a little more work, but it can really help make these a little more simple. Okay, so I'm going to have you go ahead and try number 4. Okay, so here's a good time to pause the video. I will go through it in just a second, but pause the video and go ahead and try this one on your own. So thankfully, this one's already set up. I've got my parallel lines already down at the bottom. We've got our top left, bottom left, top right, and bottom right. So if we set up our proportion, top left over bottom left equals top right over bottom right. Then we get EC over CF equals ED over, ED over DG. And so that's 32 over 24 equals 40 over X. Again, cross product, 32 times X equals 24 times 40, which gives us 32X equals 960. So divide by 32. Divide by 32. X is going to give us 30. Hey, that one finally came out nice. And so that distance there from G to G is 30. So the next thing we have is the converse to the triangle proportionality theorem. And that one states that, oh, there we go. That one states, okay, give me just a second. Okay, sorry about that. So now we're going to work with the converse that says the opposite of that. So if we can prove that those proportions are true, so if we have a triangle and we can say, okay, the top left over the bottom left is equal to the top right over the bottom right, then these two lines here, EF and BC, have to be parallel. Okay, so it goes both ways. If I'm trying to prove that those are parallel, I have to prove that that ratio works, that proportion works. So, number 5 here says, applying the converse of the triangle proportionality theorem, verify that these line segments are parallel. So, hopefully you can see that these are the two line segments we're talking about, MN and KL. Okay, so that's where we're looking right there. I want to see, are those two, I'll highlight those, KL and MN, are those actually parallel? So if that worked, okay, again, I'm going to draw my triangle here. Redraw it. And up at the top, we'd have letter J. Down the left side, I'm going to rotate it up this way. And then we have letter M, letter K, on the right side, N and L. And so we'd have our top left, our bottom left, top right, and bottom right. And so if we set up our proportion here, we're going to have JM over MK equals JN over NL. And so, again, our whole goal is to show that these fractions are equal. If they are, then my lines are parallel. If they're not, then they're not parallel. So as we substitute in our values here, 42 over 24, 21. Has to equal 30 over 15. I want to see, can I divide 42 by 21? The answer is yes. We can divide both of those by 21. Or you can just do that fraction, 42 divided by 21 is 2. 30 divided by 15 is 2. And is 2 equal 2? Yes, it does. So we can then say that line MN is parallel to KL. So if that fraction didn't work, I would say that they are not parallel. But since they did come out to be the same, we say that those two lines are parallel. Okay, so go ahead and pause the video and actually, you know what, let's just talk about this one. So for number 6, first of all, you should notice some things. You'll notice that there's only 2 pieces of information here. So if that's the case, right, again, we're still looking at these 2 line segments, DE and AB. We're trying to figure out if they are parallel. So if we redrew a triangle, we'd have C at the top. I'm going to rotate it up this way. It looks like it's a tree falling over again. So we have C, D, and A. And then on the right, we have E and B. So we'd have CD over DA equals CE over EB. And so we know that CD is 20. DA, we don't know anything, so we're going to call that X, equals CE, which is 15, over EB, which I don't know, and I can't say X again, so I have to use a different variable and call it Y, because I don't know. If I say that that's X and that this is X, then you're saying that those 2 things are equal, that those 2 distances are equal, which they might be, but I don't know. And so since they're 2 different unknowns, right, I don't know what AD is, and I don't know what BE is. Since they're completely different, we have to use different variables. So one of them can be X, the other one can be Y. Again, you can use any letters you want. That's just the ones we use most often. And so at this point, there's nothing really to show me enough that says that these are going to be usable. Okay, so at this point, I can't use anything else. Now, if we said, let's add to this, okay, so at this point we don't know. So if we add to this and say that AC is 36 centimeters and that BC is 27 centimeters. So if we were given this information, okay, I'm just kind of adding to this here. Well, if AC is 36, that's this whole distance here would be 36. And since this first section from D to C is 20, then A to D has to be 16. So now we can put that over in our proportion. And if BC is 27, so that whole distance is 27, and this first part is 15, then the left side is 12 centimeters. So in our proportion, we can replace that with a 12. And so if we reduce both fractions on the right side, we can divide by 4, and that'll give us 5 over 4. And on the right side, we can divide both by 3, and again get 5 over 4. And so since both of those are good, we can then say that DE, our line DE, is in fact parallel to AB. So DE is parallel to AB. So number 7, it says in triangle ABC, XY is parallel to BC. Use what you know about similarity and proportionality to now identify as many different proportions as possible. So there should be quite a few of them that you know. I'm going to let you fill that out and kind of see what you can do from there. And then I'll check with you guys then next time we meet. And then the essential question, go ahead and write a response to that as well. And I'll see you guys next time.